I saw in a video. The one question I did want you to go through was problem 15.
I want to solve
Homework
15
14.
now.
Yeah, together, please.
Okay, sure. Again, this problem homework 15 or problem 15?
Homework 14.
Homework
Problem
14.
15.
Except homework 14, you could solve. I think here also you have problem, right? Or not?
Yeah, that's also a problem, but I'd like to go through problem 15.
Okay, sure.
Yeah, homework.
Okay, for homework, this problem 15 means hardest problem of AIME, right?
Yeah.
Do you remember we solved a SUMaC problem? I think in first session or second session, it was related to casework.
Yeah, and then every casework question you're gonna say is like easier than that.
Exactly. The difficulty of that is 9, the difficulty of this is 20, okay? So it is much easier. I can say if that one is 90, difficulty of this one is 20.
Okay, why?
That one was hard. So it says find a number of rectangles that can be formed inside a fixed regular dodecagon, where each side of the rectangle lies on either a side or a diagonal of a dodecagon, and the diagram shows 3 of those rectangles. 3 of those, one of them this, one of them this, one of them this, right? Agreed?
Wait, what?
Here it says in this figure, we have 3 rectangles. We have 3, okay? Let me copy a dodecagon from Google to work on that, okay? So, now it's good. Okay, now here, let's consider this 1, it is 2, it is 3, it is 4, 5, 6, 7, 8, 9, 10, 11, and 12. And let's see, we can do what here? Here we want to find rectangles, so we should consider slopes. For example, it is a side, it is also parallel to this side, right?
Yeah.
So these two sides are perpendicular to each other. That's the reason we can create some rectangles, right?
Yeah.
So first type is that we select, for example, two slopes that are parallel to sides. For example, I can consider this side and this side, okay? These two sides are parallel to each other. So if I calculate how many rectangles these two sides or these two slopes can create, then I should multiply this by what?
I should multiply it by 4.
By what?
4?
No, not
4.
No, not 4. Pay attention. No, not 8. No, not 8. So pay attention. Suppose we consider all things, for example, rectangles that are parallel to these two slopes. Okay, all of them. Then we should multiply this by what?
Wait, consider.
Let me tell you. Look, this one is parallel to this one, right? And this one. Now, these two lines that are parallel to each other and these two lines, they are perpendicular to each other, right?
Yeah.
For example, here, if you see, we should consider these two slopes and this one, right? These rectangles correspond to these 4 sides, right?
Yeah.
So these 4 sides correspond to each other. So if we calculate all rectangles, for example, that can be created by these 4 sides, then I should multiply by what?
3.
Exactly. Good job. Because again, For example, this one, we can consider this one, and this one, and this one, right? And then 4 sides that are left. So, one type is this, what?
I'm just chat. Can you show me the 3 rectangles, which the question says?
This rectangle, this one, and this one. Okay. Now, what?
Sorry. So why is there an extra diagonal cutting across?
This one?
Yeah.
We should consider all of them. It is only an example. We should draw all of them and we should find all rectangles, okay? It is only an example. It says, okay, these are, for example, 3 rectangles. We should count all of them, okay?
Okay.
Now, case 2. In case 1, the sides of rectangle are parallel to sides of dodecagon. So, we can have also another case. This side is parallel to this one, 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 okay? And it is perpendicular to what? To this one, okay?
Yeah.
So can you tell me if we calculate this, we should multiply this one by what?
If we calculate, become what? 3.
Exactly, we should multiply this by 3. So let's focus on this one first, okay?
Yeah.
So let's focus on case 1. And I want to draw all lines that are related to this. So for case 1, I should draw this one, this one, this one, this one, and also these lines, right?
Yeah.
Okay, now I should see how many rectangles can we see on this figure, okay? If you want to say one case this, 100%, we will miss some rectangles, right?
Yeah.
So we should use casework. My casework is what? I want to calculate each rectangle by this vertex, okay?
Okay.
From this vertex, top left. So, can you tell me this vertex can be top left of how many rectangles?
I know I'm supposed to be not.
Can you say it again?
No. I was gonna say I know I'm not supposed to be like physically counting how many, but
You can calculate. You can say, for example, 1, 2. That's okay.
okay. There's 5.
5. Okay, let's check. 1, 2, 3, 4, 5. Exactly. We have 5. Let me maximize and let me write it inside 5, okay? Now, let's calculate, for example, this one. For this one, it is what? Count it.
9.
How many?
9.
Exactly, because 3 vertical, 3 horizontal, right?
Yeah.
Okay, so 9. Now, let's calculate some other points. Let me write 9. What? Do you agree because it is 5? Similarly, this question mark is what?
That's also 5.
Exactly, this one is 5. Now let's count other things. So count this one, this question mark.
Is that not okay. 1.
Exactly 1. And because it is 1, this one is also 1, right?
Yeah.
This one is what?
1.
Exactly. This one is what?
2.
2.
2.
No, not 2. Oh, let me think. No, not 2. Try again this.
3. Sorry, meaning no.
Exactly 3. 1, 2, 3, right? Okay, because this one is 3, this one is also 3, right? Now what about this one?
3 as well.
Exactly. We can say 3, and this one again is 3, right? Now what
Yeah.
about this one?
8.
Yes, you can say 1, 2,
Oh wait, no, it's not. It's 7.
yes, because this one and this one will be outside. So 3 and 2, 6 plus 1 like this, 7, right? And
Yeah.
this one is also 7. Similarly, this one is what?
Oh, so that one is 6.
Exactly, because 2, 2, 4, and 5, 6. Good job. So we've calculated all these things. So how many rectangles are there in this case?
You add them all together. So, 54.
Exactly, it is 54. And then it will be 3 times 54, right? 3 times 4,
Yes.
12. This, right?
Yeah.
Now let's try this one. Case 2. Okay. So
Yeah.
for case 2, again, let's draw all these lines. This one, this one, this one, this one, this one, right? On
Yeah.
all of them. Okay, here you can calculate again rectangles like this, for example, 54. Want to do it this one step by step together, or want to do it completely on your own? Which of them?
I will try on my own.
Okay, sure. Calculate these. I go and come back in 2 minutes, okay?
Okay.
Okay, so sorry, I think it was disconnected. Okay, so let me share it again. See my screen?
I think I got 50.
50.
How about how long? I did got 50.
You got 50?
Yeah.
Let me check it. 50. It is near the answer, but the answer is not 50. So let's check together. Let me check it. This one is what?
Nth of 1.
Exactly. This one is what?
1.
This one.
2.
Yes. This one.
2.
This one.
3.
This one.
I got that one wrong. That one is 5.
Yes. So your answer will be what if you correct this? Exactly. 51 is the answer. Good job. Yes. So, yeah. Yes, symmetry, right? I thought that your right answer is here because I said if, for example, you calculated some of them 4, then your answer should be 2 less than or even number less than the correct answer. You didn't pay attention to symmetry. Pay attention always to these things because it helps you to, for example, it is good for your time. Okay, you can calculate half of that. So this one is what?
Which one?
This one.
Oh, that one is that one I got as 4.
Yes, good job. This one will be 4, right? So this one is what? 2, 1, 2, 3, 4. Yes, completely correct. 8, 8, and this one is what? Yes, 3 times 3, 9, minus 1, 8. 1 plus 1, 2, 4, 6, 9, 14, 18, 26, 34, 39, 43, and 51. So 3 times 51, 153. And this one, 162. So the answer will be what?
So the answer will be 162 plus 153, so 315.
Yes, good job. Now that we solved this, do you agree this problem is much easier than SUMaC problem?
Yeah, but how are you splitting like the two cases?
Because I paid attention that each rectangle, how can we create right angle triangle? I saw by this example in the problem, I saw okay, these sides are related to each other, right? These 4 sides with these slopes. Then I said, okay, we can rotate and we can create 3 sides.
Yeah.
Then I said, okay, what are the other slopes that we can use? If you consider, for example, each diagonal, it is parallel to this one, parallel to this one. So if you go near to a vertex, it is parallel to a side or something like this, these diagonals, okay? Then I saw, okay, for sides we have these, for diagonals, this one, and for example, these things. They can create triangle. And then again, we can create 3 of them, okay?
But why couldn't you have drawn the diagonal like 1, 4? With that?
1 to 4.
Yeah.
1 to 4 is parallel to 2, 3, right? So we calculate 1, 4, but 1, 4 is related to these lengths. 1, 5 also we are calculating 1, 5. 1, 5 is related to 2, 4, right? Each diagonal is related to a side or a diagonal like this, right?
Yeah.
Okay, now one homework is left, right?
Yeah.